welcome to the stream. Uh, my name is Eero Laaksonen, CEO, one of the founders at Valohai, and then we have here
Arni, I'm CTO, one of the founders of Valohai.
and today we're gonna be checking out some machine vision examples, some simple machine vision examples.
Yeah, I think you were the father of this idea, this particular idea. So
Yeah, but before we do that, I wanted to show you something. I didn't tell you about this, but Arni, both you and I, we are a bit of the tinkering kind, and you have a 3D printer at home, right?
yep.
I think a lot of the audience might have too. Yesterday in the evening, I put out a 3D print and or the printer to print a relatively large print. And in the morning, I was happy to find that I had made something that I have never done before. It's an embedded 3D print.
Nice.
It's embedded with the cabling of the hot head.
So it's not just spaghetti, but it's a functional print.
Yes, it functions as removing the cable from the hot head. So yeah, my nozzle got stuck and it made this beautiful, I don't know what.
Organic blob.
Yeah, and it got attached to all the cabling in the hot head. So yeah, I think I'm gonna be ordering some spare parts.
Yeah. Well, I mean, you have a fairly mainstream printer, so it shouldn't be a problem.
Yeah, it's just I needed the part today.
That's unfortunate.
Okay, today we're gonna be doing a machine vision example inspired by a lot of YouTube shorts that have been coming my way. Have you already seen these betting sites? We don't endorse betting at all, but I think there's been this funny trend of betting on the amount of cars crossing a particular crossroads or cars crossing a road. Have you seen any of these?
Recently, yes, almost as if you had shown me one today. But yes, so basically betting against just pure entropy and maybe slight statistics, depending on where the target street is, I guess.
Yeah, I'll show you an example. Let's see if I can find a video. Yeah, so this is what's been all over my shorts lately. Let me share. So here, oh, there, all kinds of how many cars cross this particular spot on the road. And I got inspired. That's a machine vision problem, right? We can do something like that. I think it was a nice example. So I asked a friend to set up a webcam for us, a webcam stream, who happened to be living next to a road. So we have a personal private video stream of a road. Arni, are you able to show that?
I think I should be. Let's see. Yep, just let me drag the window to the correct screen.
Cool, yeah. So Arni, how would you go about tackling something like this?
Yeah, so I guess the most eagle-eyed of you already noticed there's something we cooked up just now in the background, but it's basically just an example from Ultralytics, which is a library and a company. They provide machine vision stuff. So basically, let's see. So YOLO was one of the first actually cool or actually efficient vision models that had tracking and all that sort of stuff. It was like more efficient than many or practically any solution at the time, and then kind of Ultralytics took over it, and they've been developing it and packaging it to a library, and they have all sorts of like analytics and training services and whatnot for YOLO and various versions of YOLO. But basically, what we're looking at is indeed a multi-object tracking problem. So you have detection problems. So you'd want to predict from a model from an image, for instance, where there's something in the image, but there's also the added challenge of tracking an object going across video. So basically going across multiple frames, which, I mean, video is just multiple frames, one after the other. So yeah, so Ultralytics is basically the easiest tool to go about this. So that's what we're using today.
Okay, so basically we have the object detection problem, and then we have some kind of like keeping track of the entities over time.
Yep.
So some kind of temporal element of
Yep.
keeping track of the entities.
Yep, and not only that, then there's also re-identification here, which is basically, say, when something goes, let me see if our example stream had something for that. Well, basically, if we had like a bus going here, and then a car goes behind it and then reappears after the bus leaves, then we will also need re-identification, which is also like a single flag for Ultralytics. But yeah, then you'll have the same ID, same tracking ID for the same object after it appears behind the tram or bus or whatever. But yeah, there's a couple of different things. Fortunately for our stream, the basic YOLO 26N model is well tuned and has the object classes we need. So basically cars, trucks, birds, umbrellas, but basically I guess we want cars and trucks.
Yep.
But yeah, so we don't need to fine tune the model ourselves or teach it about new model classes. Yeah.
Okay, and so we're gonna be the YOLO is still gonna be the model, and what does Ultralytics give on top of YOLO?
Basically, there's if we kind of take a look at what's going on there, and it's probably not that. My bad. I didn't have the. There we go. There we go. Much better. So if you look at what it's eaten, there's. Okay. Wow. Why can't I see any of the code? Because it's not having a good time. Well, whatever. There's a lot of code in Ultralytics that does all of the stuff around tracking stuff. So basically, what you get for like free is just load a model and use a capture device, and then track something, and then you have a small configuration that lets you, for instance, configure the method if you had a moving camera. So you would use sparse optical flow, so it would kind of keep track of like how the camera is actually moving as well as the object, so it can basically track those objects better as they are moving along with the camera. And then you have the re-identification config, and that's basically it. There's also a second tracker type, BotCert. It was the first one. I didn't try the second one yet, but yeah. But basically, a lot of the stuff that's around the model that would, be boilerplate, you would have to write otherwise, you get it for free.
Nice. So makes it very easy to implement simple examples.
Yeah.
All right, let's get going. So how would you go about starting something like that? We have the stream.
Yeah. So actually, let me just show you. This was basically a adaptation of the example that they have here over here. So it's more or less just the same thing here, just formatted slightly differently. So for this example, we have a OpenCV video capture of cars with MP3 and MP4, which is not actually the stream you saw before, but if I run this, so UV run main.py, you'll see, yes, this was actually from a file I found on the internet, which has lots of cars and so on, and you can see it's doing tracking and so on. And this is basically what we will end up with, but in a different intersection you saw earlier. But basically, if you use OpenCV, as we are using, even quitting, yeah. If you're using OpenCV, you could just basically point it at an RTSP URL. So right now we have the intersection.
Can you increase the font size a little bit on this?
Oh yeah, sure. I can try at least. Yeah.
Nice.
There we go. Yeah. So so RTSP is a protocol for streaming video and audio and so on. Happily, OpenCV is able to read it directly. So if we just swap this over to the video capture, we should be, I mean, unless we are blessed by the demo gods, we should be able to just get the same stream and some tracking from there. Depending on the configuration, though, as we can see, there's a bit of occasional issues with the stream. There's a small hack that we wanted to do here, and this is probably actually not real time. I think the cars are moving slightly faster where they actually are. So there was a slight hack, and you can see there's some issues with the stream here. These are from FFmpeg, which is what CV2 OpenCV is using behind the scenes. So
can you explain OpenCV for me?
Yeah. So OpenCV is one of the grand old men libraries of computer vision. It has. Let me actually just pull up the slide for it real quick. So yeah. No, that's a company for it. Okay. Anyway, so basically it's been around for ages. Yeah, 25 years. Some of our viewers are probably younger than that. But yeah, basically it has tons of different computer vision and related algorithms that are packaged for Python in the OpenCV Python library and so on. Let me see if resources maybe. Anyway, but yeah, basically it wraps a lot of signal processing and vision tools and so on. For our purposes, it just gives us a way to read a video stream. It would also give you a way to publish a video stream and so on. But and if we were using a local webcam, then we could just leave the whole argument out of here, and it would probably show you my face and track it. But for our purposes, we wanted to either read a video file for debugging, or for this purpose, we are reading a RTSP stream. And yeah. So, but yeah, basically for our purposes, we're just only using the video capture, but you can do bounce detection or edge detection or even object detection, really cheap object or face detection and so on. All of that stuff that isn't necessarily deep learning based YOLO is available in OpenCV basically.
Nice, thanks for the explanation.
Yeah, of course. But
so
yeah,
we're taking we're taking the stream in with OpenCV, and then we're doing what?
Yep. So first we're initializing the model. So it's just use this model. It will download it from the internet. If it doesn't have it, it's a fairly tiny. Let me see if there's a tooltip. If there's no tooltip, I will just. It's like 5.5 megabytes, so a tiny little model, all things considered. Yeah, so we're initializing it. Then we initialize the capture object, and then while the capture object is open, so everything is Gucci, then we read a frame from it. If reading the frame is successful, we'll get back to this. If it's not, then we do nothing for now. and that's basically what we do for CV. If you have any source, so frame is actually a NumPy ND array. So if you have anything that can give you a NumPy array of pixels, then you can use Ultralytics YOLO with it. But this just happens to be the easiest way to get like live input from somewhere.
Nice. And I assume you built this with Claude.
Well, actually, this thing here is basically just a copy paste of the example they had on
okay, you just changed the URL.
Right? With a tiny little thing that I noticed while I was debugging with my own face as a stream. So it was basically a little gotcha that we had with OpenCV is that it wants to, which is kind of sensible, it wants to read every frame of the stream. But since we're in different cities and there's like buffering and everything going on, we want actually real-time information instead of like fastidiously reading every frame and parsing those. So instead, there was a tiny little thing that Claude suggested, which is this frame reader object that I need to import from our other file. So it's basically just a thing that wraps the zoom again. So wraps this video capture, and that's a little background thread to read from the capture device, and then just keeps the last frame. So basically, we are kind of losing timestamps and losing like the coherence of like each frame following the other. But what we're getting instead is real-timeness. So when frames are coming in over the internet from the intersection somewhere in Finland, we are getting them in more real time than we would be just buffering all of those frames. So yeah, so that was a tiny little thing that might bite you if you're doing real-time stuff, but it's also like not a big deal to fix. Yeah, so with that in place, if we run the thing, I will again need to pull it in onto the correct screen. So now we have what looks like an actual speed of traffic and not the slow-mo we had before. Actually, let me just switch to the slow-mo for a moment. And yes, before you ask, yes, Python did crash there. I suspect it's because I'm not closing everything correctly in the RTSP reader thread. But yeah, now we are using the non-real-time thing. Yeah, I don't think that guy over there is that slow in real life. So,
neither are the cars, I think.
Yeah. So we're definitely like.
So we're buffering a lot of frames and not.
Yeah, we're buffering a lot of frames, and I suspect. I suspect some of the corruption here is also due to us losing frames, and then probably there's like an OpenCV or FFmpeg internal buffer that kind of fills, and then we start losing stuff, and then we get like those. That's not a fire hydrant. Then we get like H264 ghosts and so on, and yeah. So that's why we had this little real-timeification hack over here. Okay, but yeah. So yeah, I guess we should go.
So let's look at it working for a little bit. I want to see.
Absolutely. Yeah.
Okay, so we have out of the box identity detection from YOLO. It does detect things like people and cars.
Yep.
And 2 people on a scoot.
Yep, totally legal, not a problem at all. I'm sure that's a green scooter, so I'm sure Ride would want to see this.
Yes. And then it also, and then Ultralytics on top builds like these movement paths and gives identity IDs, right?
Yeah, so the re-ID and ID tracking is giving all of the objects as they appear and disappear sequential IDs. So let's see, actually, Trying to see if there's a good example, but well, just a moment ago, you could see a car going behind another car and then reappearing with the same ID. So the re-ID thing is working correctly.
Nice.
And even if the car object changes the object class it belongs to, so you can see some cars becoming trucks and then back to cars, the ID stays the same.
Yeah.
So for our totally not gambling purposes, we would be fine just looking at objects that are either car or truck, and they appear in a target area.
Okay. And now let's say we want to now track how many cars pass this, let's say the crossroads on the right.
Yeah.
Or
So
the pathway, pedestrian
yeah,
walk.
like we see the person here.
Yeah.
Yeah, I think we want to be. Oh yeah, by the way, the motion tracks here that you see, the white ones, they are actually our client code. So yes. So basically, let's just go quickly through the whole code. I'll actually do this because I want my code to be less indented. Yeah. So basically, all of the hard work is happening here. So we are telling the model to track from this frame. We don't want it to spam our console because we don't care. It would show more stats about what's being tracked and so on. Persist tells it to use the last frame it tracked as a reference, so it can do those tracking and like persistent ID and so on. This configuration YAML was what I showed earlier. So basically, just a couple of these are actually all the defaults. But if you are passing in a YAML file, you need to pass in all of them. So that's why they're here. Well, actually, okay, the re-ID was not the default, but I set it to true. Now it's being re-ID. But yeah, this was also from the Ultralytics side. Yeah, then if we get some boxes in the results, because the result can be it's a results object from YOLO. It has like the original image and boxes and masks and so on. So if you're doing like segmentation, so with like SAM tree, which is Meta's segmentation model, which is pretty cool, by the way. I've contributed to a project called Label Me, which is basically for data labeling or image labeling. So it has a mode where it can actually use SAM tree to automatically segment an image to like semantic areas, and then you just tag it. Okay, this is a car, or this is a dog, but you don't need to like do the whole,
Draw the polygons and
so on, yeah, by hand. But yeah, this can also do that, and then key points and whatever. But yeah, what we are interested in is the boxes, and then for the boxes, they are also it's a boxes object, obviously, and then you can figure out if it's a tracking thing or just a box. So we are only looking at the first result. Could be more. In this case, there's only like only single result object with boxes. And then getting the boxes is coordinates as like x, y with height, moving them to the CPU, because I'm on a Mac, so I think this inference is actually running on the CPU. I can actually check by looking at the gauges over there. It's running again, and now we can see the verbose dumping here. So we're doing 40 seconds inference per frame, which is okay in my books. And judging by this CPU gauge, we're doing it on the CPU because the GPU is kind of sleepy. Usually, if you're doing like local LLM inference on a Mac, then these are all maxed out. So I'm pretty sure we're not using MPS or anything here. But yeah, it's good enough for us. And if YOLO Ultralytics is trying to use CUDA or whatever accelerator you have, if it can, but we don't have anything that's like 100% compatible, so it's defaulting to CPU. But yeah, so yes, and again, it's question. So just doing quickly, like we have track history, which is a default big. So basically, we're looking at the track ID, which is the ID you can see in the image, and we're keeping track of that ID's points. And if there are more than 60, then we just remove them. This is all just from the example. So basically, just taking all of the tracking lines for this box or the coordinates, and then just plotting them as a single polyline. So basically, a multi-point line. We could make it a little more obvious to see by changing its color to red, because there we go, red, yes, blue, because always trips me up. OpenCV images are BGR, not RGB, due to historical reasons. But yeah, now they're blue, like in the A465 song. Yeah. So, and also result plot is doing a lot of the hard work here. So if I just remove this, then we will probably see, yeah, so we don't get the labels anymore, but we get the track that we draw ourselves. So basically, result.plot is a quick shorthand for just seeing the IDs and so on of the results. But yeah, now we get this cool. I think actually you could make an art installation of this if you just plot the trails and nothing else over like a day. Would be kind of cool. Anyway, let's put the plot back in. Let's get back to the plot. Yeah, that's basically it. So now we have a way to see these objects, see where they're going. I guess next we would want to see the figure out the coordinates for the zebra crossing.
Yes.
And then work on that. So I guess this will need some manual work, I believe. I'm gonna just add some coordinates to begin with. Libra y, actually that should be probably Libra y1. Yeah, sure. And then I'm gonna hope GitHub Copilot is doing the right thing. So the rectangle, yeah, sure. Yep,
nice.
Exactly what I wanted, and then I close the file. Yeah, okay. So hopefully we'll see something here. Yeah, it's that green rectangle. It's almost correct, I would say.
Yes.
I.e. not at all. So we're gonna do something about that. So it was 500. I think we're doing 1080p, so it's somewhere between like, actually, well, I can just do like, let's see, 0.65, 0.75. If you were doing this in production, you would probably want all of your coordinates to be like normalized form like this, and then you wouldn't have to care about the size of your stream. But for the time being, we're just doing this. 1080. That's pretty. Yeah, actually, it needs to be like, yeah, something like that. And let's see. Move. Needs to be in. So I could probably cast this or something, but it's fine. We'll do this. Let's see again. Yeah. Okay. So that's a bit better. I think like point some pixels over there. So 0.6, and then going like this. Yeah, and if you were like feeling fancy, you could actually do this like in Label Me or whatever, whatever mask app you wanted. So you would just paint over the area you wanted in production. Again, if you were to run a site where people can guess at things. Yeah, but I think this is good enough for us. Yeah,
I think so.
So yeah, basically.
But I mean, let's move the lower bound a little bit higher.
Lower bound is higher, sure. So I'm gonna just.
It's annoying me a bit.
Yeah, 0.8 should be fine. And one more time. Yep. And then that good?
Close enough. I think some OCD
Yeah.
watchers will probably not be happy
Yeah.
about this decision.
Yep. So I think what we want to actually do is instead of doing this, we will. Yeah. So let's take this. Wrap it in a. So no, wait, hold on. Yeah, we don't need to do that. We just need to read a bit closer. So result dot boxes. Let's tell the Copilot what we want to do. Yes, maybe. No. Yeah, sure. Yeah, you're getting there. Sure. Uh-huh. I think this might raise because we are not testing them the CPU. Index 2 is out of bounds for dimension. Is the X1? Yeah, it's an unlimited. Oh, it's boxy. No, wait, why is it boxes is this? Yeah, because it's for all of the boxes. Yeah. What? Yeah. I'll just do this instead. We will still get the plots for everything, which is not necessarily well. Actually, yeah, we get what we want in a sense here. So if we could just get it, oh, sorry, my bad. I'm looking at the wrong screen. So we still get the plot for everything, which is not exactly what I wanted, because it would be more obvious to just see. But we should get the trails only when an object is crossing that area.
See.
Yeah. So getting a trail. There we go.
Yeah.
Getting a trail.
Yeah.
Okay. So I guess now all we need to do is bring IDs in our Libra area as a set, and let's do log messages. All messages append. Oops. That's good. And then let's print like the last 5 messages. Yeah. CV2 put text. Yep, absolutely. Yeah, sure. Something else. Yeah, I think we'll want something more than this. Font, face, font, scroll. Sure. And also we will want this to be like it's probably not enough. So like actually let's move this to like 5 and 5. Let's see how it happens, how it goes. Oop, it didn't go. Yeah, because I'm a silly goose and I forgot the enumerate I was thinking about because I was speaking at the same time. And yeah, there we go. I'm happy that wasn't RMRF, but it was the other command. So now we have no plots as is the plot, and basically, let's see. Yep, we see some logs here, so but they are really tiny and aligned badly. I'm just gonna maybe print these at like 720 and 10, whatever, and maybe in white. Yeah. Now they're a bit big, maybe. Font scale 20 was a bit
We
too
can't
much.
see.
Yeah, I can just about see the text. Sorry, yeah. Oh, wrong screen again. Well, I'm glad you didn't see my mistake there. There we go. Should be, yes.
Very nice.
It probably would be a good idea to also show the class of the thing.
Yep.
So let's see how that is in the API. Since we have, yeah, so these are all stacked. So I think boxes. No. Actually, let's see what plot does. So it's blah, 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 annotator, blah, blah, blah. Example, names, self-def names. I would imagine that's what we want. So yeah, it's names. It's a date of int string. So I would hope it's keyed by the track ID. So let's see. Names get track ID. I'm just gonna be defensive and
See.
Yes. And again on the correct screen, we have the plot again now. But yeah, giraffe, surfboard. No, they are not keyed by by the track ID. I think
Teddy
they
bear.
are by the class ID. So I think we need to get the class of each box first. CLS. Yeah, that's what we want. So insult boxes CLS. Yep, the same thing, and then we zip these here, classes, and then classes, not classes, class ID, and that's hopefully more like it. Yay!
Nice.
A bus and a
Oh,
car.
there we saw a car
Yep.
that was behind
Yep.
another car. Object permanence, we have it.
Yes. We
You
also
get
have
so much for free right nowadays. You get so much for free nowadays.
Yeah.
Okay.
So, and then next you would probably yeah, let's do the big counter thing as well. So let's see what was the name? IDs in Zebra area. Actually, let's make IDs in Zebra area a thing of classes, data class, pros and equals to detection, class name string, IDs int, and then rename this to debts in Zebra area, annotated a bit, so we're up here with the IDE. And that's in this and this and detection. Class name is what I get next, so I'll just do that. Class name equals name. Yes, exactly. Yes, I know it can technically none, so let's do that. And now we should be able to do something like stats equals, yeah, yeah, thinking what we want to show here. Well, let's do this. The class name for the index and zebra area values. And yep. CV2 put text frame class stats most common. Yep, absolutely, exactly, yes. Except not at 720 or just 220. What we're missing, I mean, this stringify that because it is strict. Yep, and there we go. Now we see 3 cars, 4 cars, 5 cars, 6, 7 cars, 6, 7 cars. Yep. So yeah, it didn't take too much to build this infrastructure.
No, it's pretty freaking fast, and you actually wrote the code yourself this time.
Yep, I did have code ready to go, but this was simple enough, and I wanted to learn more about what I'm doing, so it was easier to just write it myself with the assist of like Copilot for the boring stuff, like figuring out which arguments go where and so on. But you know, that's yeah.
Could we give a shot to having Claude build us a nice web UI that runs locally for starting a timer, click a button, and then that will do like 1 minute and count the cars crossing during that minute.
Sure. Yeah, let's see. I will do my my trusty WIP commit. It will just do a WIP. But yeah, I want to have my current state somehow in safe hands before I give it to Claude. So yeah, let's see. Could you do this? A vehicle detection game here in main.py. Could you write a small standalone web UI that would show the current frame, which has a bunch of current frame from the game, along with the class stats counter data in, and also have a button to start and stop. Well, start a 60-second timer. The objective of the game is to guess the total number of things in class stats by the end of that time. So I wanted to give it a little more context here because it usually does a better job at that.
Yeah.
I'm a bit curious to see what I'll do to wrap this in a web serverable thing, because that's usually like a friction thing.
Yeah, I think that's gonna be interesting on what does it choose to expose all of the internals of the, because I think it's gonna need some kind of API to talk with the
Yep.
with the machine vision model.
Yeah, generally, if this was a larger thing, I would probably use the plan mode, because Claude Code is surprisingly good these days at asking questions to clarify what you're meaning or how to do things. It's actually, I noticed it's also also in the Claude chat. So I was, yep, That looks good. Tiny standard HTTP server looks good. Yeah. Latest JPEG will mean that it will not be quite real time there, but it's fine for the MVP. Doing real time would mean we would have to do HLS, which is HTTP live streaming to like expose segments of like video to the client.
Yeah.
Yep. Okay, so it basically just copied everything. I do not want that. Please refactor main pi to a function, whatever you need, instead of copy pasting everything wholesale. Thanks.
Yes, it being so nice to our future robot overlords.
Yep. I'm old school enough to remember that there was a time when the models did act nicer when they were being nice too.
Yep. I've been very impressed by the plan mode.
Yeah.
While trying out the kind of giving larger tasks like this. I think it also gives you a really nice back and forth to kind of point it to the right direction.
Yeah. There's also, I don't know if you noticed, this Ultra plan. I haven't tried it, but
I haven't either.
yeah. But it apparently does even more than. Yeah, okay, that looks more like it. Yep, I am okay with this. By the way, did you notice how it's integrating into my IDE for those reviews?
Yeah. Pretty cool.
Yep, and also if I were to select text, you would see it over here in the.
Yeah.
So if I choose something over here and then, can you tell me what's wrong with this code? It would be like, oh, you're a dumbass. You know? Yeah, no, Claude is nice. Claude doesn't say that. Yeah, and now we have a separate web game.py that's just, yep. Yeah, I will tell it next to, I would, if I cared more, I would tell it to move the HTML to some different file. End of file bytes. Okay, sure, you can read what's. Why would you do a hex dump of it? Okay, sure, you can append a new line. Fine. I mean, the linter would have done that. It's fine. Okay, decided this was a memory that it should remember that I prefer refactoring instead of copy pasting. Well, yes, you're not incorrect there. But yeah, soon enough. Yep, absolutely. So let's see then. If I run webgame.py, yep, and serving on this, yeah, there we go. So, yep, let's start. Yeah, it probably should have reset the count, but it's whatever.
Yeah.
Because, well, I mean, the state is on the server. It doesn't have a way to reset.
So close. Why is no one moving? Nice.
Also, we're not limiting the classes of the vehicles to just car, truck, bus, train, which we probably should do for production, but you know.
It's just come on. Come on. So close. No.
Oh well, maybe next time. I'm glad we weren't, using actual money for this.
Yes. So let's add let's limit it to just cars. Let's move trucks and buses, only cars, and then reset the counter.
Sure. Couple things from our live review. Let's add a way to actually reset the state on scene state on server when we start the timer. Let's limit the detection classes to cars, trains, trucks, etc. Maybe
No, I
figure.
want just cars. Just cars.
Yeah, but some of the cars, some of the like cars may appear first as trucks, and
Sure.
in our game
Okay.
here we are only using the first class ID we ever see the object with. So
Okay. Well, ask it to fix it.
no, that was on purpose because I didn't want it to like have
Yeah,
have
it's fine. It's fine. It's fine.
clutter there.
It's fine.
But
This
let's
is
see.
not going anywhere, actually.
Yeah, maybe figure out the class names the YOLO model supports and figure out which are vehicle. Because I want to kind of see if it figures out how to read the class names from the model, or at least introspect it somehow.
Yeah.
Thinking some more. Oh yeah, meanwhile, while it's not writing stuff to, yes, I will do a WIP commit as well. I generally, when I'm working with Claude Code, I do a lot of those WIP commits, even if Claude itself has a history thing. I want to kind of just use Git, and I will then clean up those WIPs later on and so on.
Yeah.
Yeah. Okay, so I'm not sure. Well, it just knew that they are Coco classes. So Coco is one of those data sets of like objects.
Yeah.
So basically they've trained the default model with the Coco, so it knows it. So it didn't have to look into the files, which is unfortunate. I would have wanted it to. Actually, can you double, triple, quadruple check that those? Yes, I will let it accept edits for now. Those IDs are vehicle from the actual data, not just their innate knowledge of Coco. Yep, so now we just ran UV run Python to introspect the stuff, and then we can see what it printed out. Yep, so yeah, fine, airplanes and boats won't cross a zebra crossing, fine. I'll allow this. Okay, yeah, also it's just this skateboard as well, but I didn't see any skateboards there, and that's not our game, so we're just gonna. Silly Claude, you did a syntax error. Why? Yeah, so we're just going to do this and encode it over here. So it was trying to be too clever. But yeah, now we need to open the page again. Yes. Okay, so it's about that time, so I think it's going to be a little busier.
I'm going for 6. Oh no. Oh no. Oh no. I guess there's some traffic over there because the cars are constantly stopping.
Yeah.
We got one.
That was arguably a miscount because it counted the tram that was going left as both a train and a bus.
Did it?
Yeah. And I think we might get, yep. Oh no.
I was closer. I wanted 6.
Yeah. Well done. You win a token. You get one LLM token.
One LLM token. Oh
Yes.
my.
You
On any model.
Yes, sure. Any model on an open router, you get one token.
Okay. I will hold on to that token.
But yeah.
Nice.
Again, for production, you would probably not do. I think what's happening here is it's okay. Yeah, it's encoding to JPEG. You would probably actually want a video stream instead of just refreshing a JPEG over and over again.
Yeah.
But again, it's MVP.
It's a test.
You then prompt your friendly robot to do the rest.
Yeah.
Yeah.
I mean, it's a project you can build in an hour.
Yeah.
I personally think that the rise of AI coding will allow for much more usage of machine vision models going forward, because it makes it so easy to implement stuff like this for people who are not like super proficient with machine vision. And also the machine vision libraries have come so far, like we saw today. It's relatively trivial to get going on a project.
Yeah, I think the hardest technical hurdle here was to get the webcam stream from somewhere in Finland over to where my laptop is. I just actually want to give a small shout out to the media server we ended up using. So Media MTX, it's apparently written in Go. You just drop it somewhere and then you get like RTSP for free.
Very nice.
Yep, and then you can publish a stream. I think they had docs for FFmpeg. So basically just a little FFmpeg spell and tell it to do RTSP somewhere, and that's basically it. That was pretty neat. This also hasn't existed before because I would have needed this in a previous life. But yeah.
Nice library.
There's actually a example here, yeah, how you would use OpenCV to write to Media MTX. So if you now needed the annotated stream somewhere else, you could use this, or if you wanted that video installation or something from your Python app, then point your friendly robot to this page and let it read the docs. Yeah.
Nice, interesting project. I didn't know about this.
No, I didn't know about it either. It just came up as a recommendation, actually from Claude. So yeah.
Cool. Hey, that's it for today's stream. Thanks everyone for watching. I think next time we will maybe try some of the multimodal foundational models to see how much of a performance drop we can get by implementing something a bit bigger for a similar thing. Or then we'll do something completely different. We'll see.
Who knows? Yeah.
Thanks for watching.
Yeah. Thanks. And yeah, thanks for a fun project.